Example 11. An ice cube is placed in a flask at room temperature and allowed to sit until the temperature of the water has reached room temperature. Describe the changes in enthalpy, entropy, free energy, and temperature that occur during the time interval. B. 40 grams of sodium hydroxide pellets are added to 50 milliliters of water, and most of it dissolves very quickly. The temperature of the system increases. Describe the changes in enthalpy, entropy, and free energy during the process. Finally, commercial instant ice packs are available that contain a mixture of ammonium nitrate and water separated by a barrier. When the ice pack is twisted, the barrier breaks and the two substances mix. The temperature rapidly decreases as the ammonium nitrate dissolves in the water. Again, describe the changes in enthalpy, entropy, and free energy during the process. Okay, so here's the ice cube. The enthalpy will be positive since heat is absorbed by the ice cube and then the liquid. Entropy is positive because the degree of randomness of the particles increases as they disperse as a liquid. Particles in a solid have fixed positions, which is not true for a liquid. Gibbs free energy is negative since the reaction is spontaneous at room temperature. And finally, and this is a little tricky maybe, the temperature stays constant as the ice cube melts and then increases once only liquid remains. Now we're dissolving the sodium hydroxide pellets. The enthalpy will be negative since the reaction releases energy. Temperature increases are signs of the reaction giving off thermal energy. The bonds that are formed between the hydroxide ions and the water generate more energy than are required to break the reactant bonds. Entropy is positive because the solid sodium hydroxide is more ordered than the dissolved ions of sodium and hydroxyl. Entropy is dependent on the degree of order of a system. The more random the system, the higher the entropy. Gibbs free energy is negative because the reaction is spontaneous and the signs of enthalpy and entropy support a spontaneous reaction. And finally, temperature increases as that was given in the problem. And finally, we have these instant ice packs that you twist and they get very cold. Your enthalpy is positive because the reaction absorbs heat. Entropy is positive because the ammonium salts are turning from their solid state to an aqueous solution. When a substance is a solid, it has less entropy than when it is in liquid form. Gibbs free energy is negative because the reaction is spontaneous. Because both the enthalpy and entropy are positive, the reaction will have an equilibrium temperature, above which it is spontaneous and below which it will not be. Temperature decreases as that is given in the problem.